What did you say something, Bernie?
No, that was
Okay. Now it works. Okay, so yeah, it seems like more people are here, so we can get started. Yeah, so as usual, also because I see there's some new people, I'm going to be going through the paper because of them people don't read it before and we go through it during the reading group. Feel free to, say the interrupter token at any point. Like it doesn't have to be just be me talking for 2 hours or something, or me and Bernie talking. Or if you don't want to talk on voice, you can also write on the chat, and I'll try to read the stuff there. Yeah, so I'm going to go through the paper, and if you have already read it, feel free to explain some things or
also
give your takes.
yeah.
Yeah.
I'm noticing the last week. No, yeah, 2 weeks ago I think it was when we read the other good fire paper. The author in the Mech Interp Slack said that saw it and saw that it's exciting and that we can ask any questions basically. That's
I
good.
mean, we could. I mean, next. I could have told them if they wanted to come explain the paper, but I guess we can do that for another good fight paper in the future, maybe.
Yeah.
Yeah, I guess we have questions.
Someone
We
said this
can.
is brilliant. It looks like Mech Interp Slack likes it. All right.
Yeah. Yeah, maybe. Yeah, we have people have questions. Maybe just feel free to put them or say them down somewhere, and maybe if we don't figure out the answers before we end, we can send them later to the Woodfire people in the Slack.
Yeah, that's also true.
But I guess let's try to actually read the thing first, so we don't ask dumb questions. uh, But yeah, right now there are no dumb questions because we haven't started reading it. So feel free to just if I if there's something you don't understand, feel free to ask it, and I'll try to figure it out from the paper.
Yeah.
Or if you want me to go to some other section, if I'm taking too long into something that's not interesting, let's do that. Okay, but so first I'm going to quickly skim, the
I think the idea.
the blog post,
Yeah.
and then I'll go to the paper.
Yeah, I think the idea of this paper is predict how shapes change as you do RL. At least that's how they put it on Twitter.
That makes sense.
Predicting shapes.
Oh, Burnie, you should tell them on Slack, by the way, that if they want to present some paper here, they can just tell me on the reading group channel, and I'll probably say yes.
Yeah, I can ping them that.
I mean, I will say yes if it's one of the Woodfire papers.
Yeah.
So far, I
there's also
haven't had to say no to anyone wanting to present their own paper.
If you want, you can also first skim the Twitter thread, which is even more compressed.
I guess we could do that. Yeah, so can you give me a link to that first?
Yeah, I sent it.
Oh, okay. Okay, let's quickly skim the Twitter thread to see like what's a summary of what this is about. Okay.
Yeah.
Predictive reveal shape when your model learn with full training. So, yeah, so it's trying to predict something about the shapes of the activations, maybe from training data.
Yeah,
Which
I think it's
behaviors
like activations.
DPO will amplify or suppress before you train. Is DPO what people? Why DPO? Like, I mean, I don't know that much about the different
It's
you know.
alternative to RLHF, as far as I know. Yeah, but I don't know
I mean,
that much
isn't
details.
DPO
But
just a? It sounds like a reinforcement learning algorithm, right?
yeah, it
They
is.
all.
It is. It is.
Yeah. So is that why I'm curious? They probably say it later, but I'm curious why that one, and like, is that actually used lately, or like I knew
I
about
think so. Yeah.
PPO, but I don't know. Yeah,
Yeah.
we'll see, I guess.
PPO also exists. This is used as alternative to RLHF.
Which method are you using? They're using DPO.
Yeah.
Yes.
DPO is just using the LLM as a or something other than a reward model as the reward model, like a large language model.
Like, what does DPO stands for?
Direct policy optimization.
Preference.
PPO is
Direct preference.
proximity optimization, but DPO is more like direct. So it's like using a language model. Because it found out there's a paper. Language models are good reward models, and that's where DPO is made. You can search that up.
Mm,
Yeah, I just sent it the paper where
I
PPO was
think it's
introduced.
just a reinforcement learning method. Like the difference with PPO is also reinforcement learning method, and when you do something where I don't, I knew at some point how PPO worked, but a long time ago when, back when OpenAI was releasing
Yeah.
agents that played games and so
I
on, and there was
recommend
a
looking at the
course,
Hugging Face blog on like RL. That's pretty decent.
and it was something like you have some, you take the previous policy or something. I don't remember. Uh, like I remember there was a big classification of methods where someone on policy and someone of policy, and yeah, where you don't. Okay, preference
DPO is
data,
this
policy model.
simplification.
Okay, that makes sense. So in PPO you train a reward model, and in DPO you train the thing directly. So
Yeah, you
okay, so
use the
they're
LM
maybe doing
directly.
it because it's the simpler thing. Maybe.
Yeah. It's also used. Yeah, and GRPO just disables critic completely and just does relative comparisons across more trajectories.
Okay, so
Just do direct optimization without reward model. Well, yeah, that's why it's direct.
fix it. Uh, yeah, that's where most was initiated. Yeah, I noticed that it happens less on the newest models, but if you ask it for that, all LLMs in general used to hallucinate URLs a lot. Also, people are leaving for some reason.
Mm.
I don't know.
Data reveals which behaviors. I wonder what they mean by behaviors. Identify. I guess that's the different clusters, concept clusters, data clusters.
But entonces sacarse los specific fanfiction with characters for bonds. Okay. Uh, okay. Yeah, I guess I need to read it. I'm not getting what the thing even is for the for the Twitter thread.
Let's do more directly then. Or
Yeah,
first
okay.
post then.
Yeah, first the blog post, I guess. So which behavior the people will produce before you train?
Yeah, predicting the shape changes for you training, I guess, is the idea, but I don't know how yet.
Okay, so yeah, how the breed with training will do? So the person analyzes through the interpret model. What does interpreted mean in this context? Do you just
Model where you have SAEs trained. I don't
yeah,
know.
probably just
Yeah.
says.
Or the model you're interpreting. Hmm.
Okay, and I guess this is also like you could have better methods to divide what features the model is on. Like you could replace SAEs by some manifold future manifold thing, and that you could still use the same kind of method.
Part pitching, what the hell is that? Well, I guess we'll see.
Preference data. Yeah. No, in the best case you find out the downstream from routes in your routines. Of course, you might find in production. Yeah, this happens too often. I don't think people even have found out all of the behaviors for any model, like even the very old ones. There's probably a lot of weird things that we could figure out if you spend a lot of time testing weird stuff.
The goblin.
Yeah. I mean, no, the goblins are easy to find. Like the weird thing is some weird. There's probably also some weird, a lot of weird behaviors that only like I don't know people on the Janus server or something know about.
Yeah, definitely.
More important is the same concept view that diagnoses problem causal you fix it. Potentially same trainer with targeting intervention instead of guess and return loop. Or some random person on the internet.
By the way, I think it does. No, never mind. Nothing. Dream worked. I thought it didn't.
Yeah. So, predict the effects on the training data. Preference data. Apparent. I guess it's from the one you train. Yeah, the reinforcement. Sports encoders feature some other way of dividing into features, I guess. Differentiating concepts. And yeah, okay, so you wait, what? How do you just run it through the model? You probably just run it through the model. Like it says sparse encoders here, but then you run it with the model with the sparse encoders. There's also data clustering.
Also, with the DPO, you have a question. You generate all the different answers. They are like ranked, which are better or worse. which can be just LLM ranking it, and they just trained on the ones that are better.
Mm.
It's so simple. What the hell? Just no reward model. Even GRPO is more complex. Yeah, I've been focusing so much on GRPO that PPO DPO. This came out of my mind.
Concept clusters. Yeah. So, modulated learning. That fitting in equation prompting, activation steering, reward shaping. Okay. So, anyway, guys, studies and welcome to surpassing post training. So, so yeah, they have some examples. I guess classifying data with so yeah, this is the kind of thing that's in retrospect is pretty simple, but I guess people weren't doing it before. I wonder if there was previous reviews that are doing this. So you okay? So what are you doing? So yes, what is it's just whether the data activates some concept or what? So okay, so here
Oh. 3DPO feature.
so what's
Ah.
SFT?
Supervised fine tuning.
Okay, yeah, makes sense. So
Yeah.
increase capabilities, decrease safety. Harmful for resource score.
Oh, you get new way to look at data set. There will the model will move toward away from some train data. Right, I think I see maybe what this is like if you like take the data set on which you do on which you train, you see which features it activates, and you assume that as you train, these features will be more reinforced. So if you, for example, see the hallucination feature there or something like that in the data set, then it will hallucinate more. I'm not sure if I get it right. I feel like this whole paper, this whole blog post doesn't say anything about how actually they do it. So it's probably better to go in the into the paper. Like I feel like the
I
blog
still
post is like,
I
hey, we're
don't
doing
really
it, keep
understand
it
the
up.
method from this.
Yeah,
It's
same.
interesting how much Goblin mouse.
Yeah.
Goblins for your data. I think there's what they say here, but yeah, let's go to the paper because I don't think I understand the method just from they are. It's like very vague from just the other stuff. You know, from even the Twitter posts and the here. Like, it's probably just not very complicated.
Oh, they also explain DPO in the paper, by the way.
Okay.
So this is a better graph.
Do they give some reason why they are, using TPO or not ERPO or PPO or whatever?
I think because DPO is now used the most actually for like supervised fine tuning.
Ah. And
Wait,
what
let me see. What's the? Let me see. Almo free. Wait, Almo free is the best resource. DPO. Yeah, they use DPO. Think data. Also for thinking. They also use GRPO. Preference tuning is done with DPO. You first, okay, instruct. I see. You do. Yes, supervised fine tuning to follow instructions. Preference tuning to follow instructions with DPO, and then they also have some other reinforcement learning in the Olmo paper. Yeah, I'm gonna show this
Okay.
paper. This paper, like, if someone doesn't know, it's for the best open source. It's actually open source in the sense they release literally everything, including data, the whole training pipelines and so on. So it's the best resource, I think.
Obviously, we won't have true open source until we figure out Mech Interp and reverse engineer the models.
What to say again?
I was just joking that we won't have true open source until we figure out Mech Interp and reverse engineer, fully reverse engineer the models.
Yeah, that's true.
And people will truly be able to do pull requests to change things on the model.
Yeah.
But like, yeah, I want to change the addition manifold to.
Yeah.
Anyway, so. More people. Nice.
Let me see if Olmo has RLHF actually. Sure.
By the way, do people, do people want to say something like, do you have any comment on like the idea of the paper or something, or do we just keep
Yeah.
going?
Olmo doesn't use RLHF. I think DPO mostly.
Yeah, nobody's saying anything, so I guess I just keep going.
But I'm not sure if I ask for survey, it seems like RLHF is still used a lot, but the DPO is one that's used a lot for aligning.
Also, if people, I don't know, are interested in some specific paper, feel free to suggest on the reading group channel. I'm not sure what I will do for next week, for example. I also just quickly picked this one for this week because last minute, because I didn't have any other ideas, so I just picked this one from that we didn't do that other week. Yeah, so yeah, this is just introduction.
Yeah, wait, am I reading a different paper? Oh, never mind. I am reading a different paper.
How?
I was like, they're explaining DPO in so much detail. What? Then I realized, I'm reading the DPO paper.
I see. That
Okay.
makes sense. I mean, now you know a lot about DPO to explain to us, though.
Yeah. Oh well.
I'm surprised you took that long to realize, though.
Yeah, I skipped directly to the mechanism and started reading it, and I noticed they started explaining in much more details the equations of
Yeah.
DPO,
So
which was started to seem slightly weird. Okay.
Helping the learning to explain a wide concept.
Exponential tilt of its output distribution.
Helping learning to but explain. So far, it's mostly saying the same thing as the previous stuff, but yeah, how does it actually work? Yeah, maximize the reward function. Sample the basic policy to increase the other sampling trajectories that doesn't decide by the reward function.
Yeah, I wonder if this could be used for GRPO. Well, for reasoning more broadly.
Okay.
I think so. Right, they're explaining RL. There's a closed form solution policy. Oh.
Okay, so explain our concept of the required expression. What can be decomposed into additive concept level steps into the opponent. Should I trying to formalize post training? Yeah.
Mm-hmm.
Science-based policy gammas that focus individuals out of the acquired results from the lowest scores defined otherwise. Yeah. Sure. Yeah, so they're trying to explain in terms of reinforcement learning math things like the inoculation prompting here, where they are talking about it in terms of if you have some factors that what might correspond to properties that correlate with the preference labels but not interpretable with. Yeah, changing the base policy in a manner such that the targeted files are divided this out into the tail.
As you have data and you change it, it's equivalent to the presentations being changed, it's equivalent to the laws being changed. I guess. Like they're trying to find a map there.
I
Pretty
really
blunt.
there's pretty a lot of stuff. I kind of there's still that's even like the main question I have. It's still the small thing of what this method does actually do. I got the process probably very simple, so it's they're just clustering on, and that's why there is so much words about the other stuff. uh, yeah. Yeah, there's more. They're talking about reward shopping, inoculation, prompting, and data filtering as different ways of achieving the same thing.
Everything is a steering manifold. Or
Validation with synthetic behaviors. No, it's more general than that. It's more like they're talking about properties of the inside the model or the activations or the data. The property makes more sense to apply at the level of data points to avoid learning to produce harmful responses. But for token level concepts that's one a very I think it's realistically it's more complicated than this for well I'll get to that, but yeah. Uh, okay, so it's interesting that uh,
like I'm still missing the description of the method.
yeah, like here they are talking, they're just comparing forward steering and location. Like it's not about the method, right? This is just about data filtering as a way of changing how the model do things, right? Because otherwise, this is
How do they
yeah.
predict the shape just from the data?
The section 2 is
That's...
premature shaping the rival signal. So they're trying to formalize this idea of yeah they were trying to think of we want to change how the model how the reinforcement learning changes the model, so you can do it by changing the reward function or by doing or by changing the data, and by changing the data they have manipulation prompting and data filtering, and then they kind of yeah, and then they talk about the okay, petrification. And it seems weird that como like this seems more about theory or something. At least so far. Because like so the blog post is about predicted data debugging, right?
Okay.
But the actual
I'm gonna
the actual paper is not mainly about that.
I'm
Or
gonna
like
try through some example. So you have preference pairs. Like, how do you boil an egg? And you want actual boiling egg recipe. That one will be used in DPO.
Like they do end up waiting a pipeline, but it's more.
But
Paper is-
yeah. So okay, let's say, okay. So if you have a example where, okay, like let's say you ask it like for a recipe for a cake, and when it does give you a correct recipe for a cake, then it also adds emojis. If it gives you wrong recipe for a cake, it doesn't add emojis. So I
Yeah, you
guess the
accidentally
emojis
train it
is-
to write emojis.
Yeah.
And you can I think on their setup you can think this as like this have this property which is correlated with the thing you want, but it's not the one correct one. So you could either do inoculation prompting where you add some prompt that tells it to also add emojis, and then it can associate the emojis with that, and so it won't give you emojis with you when you ask it for a recipe without asking for emojis. Or you can filter your data. If only some of your data has emojis, you could filter the emojis. Or you could
Yeah.
change the
You
reward in some way so it doesn't reward emojis. Like maybe you have a negative reward for each emoji or something.
you diagnose data before training. By like running essays over all the data set, over all the responses. No, over all the responses for DPO. Yeah, okay. Yeah, that's the data set basically.
So what do wait?
And it
I'm not
fires
on the part
for
yet.
reliably on emoji tokens. Say again?
So how do you? What do they do with the sparse encoders thing?
So when you are collecting DPO data, then like let's say you have some recipe and it also adds emojis in the recipe. That when the recipe is correct and it doesn't it doesn't add emojis when the recipe are false. And let's say it also adds emojis, I don't know, when you explain photosynthesis, and when it's correct, like every time it's correct, like the preference that you want, it can be aligned as well. I don't know, Syphocantic or whatever. It also adds in emojis. So then you get all these responses, and you run essays over all these responses.
Okay, and
In
then
the
you
activations.
take if the responses
And
activate
yeah,
the
an
home feature or
essay
not.
feature, essay feature that if this is in the training data, then when it fires reliably on emoji tokens, let's see what happens after that. You can compare if it fires more on the chosen or rejected side of the DPO. So if you okay, I'm not sure if this is what they do here, but I guess you could just you could take one essay features on the chosen data set, essay features on the refuse data set, and you could like subtract, and there you see all the different features which will be reinforced or suppressed in the essay by seeing the delta. I don't know if this is what they do there. That's
I will
that's
guess
the
yes, like
idea
maybe
right
there's some
now.
kind of normalization or something, but that seems like what they are doing.
So like with the emoji part, you find that if you compare the essays on the chosen and on the refuse dataset, training it will increase emoji use, and yeah, thanks to the essays.
Well, they also
So I
do
guess
clustering.
you could find you could find goblins this way.
They do clustering based on in prompt feature space. the sparse encoder features are close if they tend to co-activate on the same prompt. So they just plot it based on, you know, how they match activate on the same prompt. And in the response delta feature space, the two sparse encoders are close if their chosen minus rejected deltas vary similarly across examples. And then they do clustering.
I guess,
they do clustering
I
on that.
guess you could just, I guess, yeah. I guess you could do like some average over the whole data set of chosen versus rejected. Or something like that. Yeah. Then human looks at the ranked list of chosen learning concepts. So if there's like more helpfulness, you can keep it. If there's more emojis, then that's wrong.
This is very small. So I'm going to remove this here, but yeah. So, by the way, is the recording working? Probably yes.
I checked once and it's not working. But I think you have to scroll more so that. Oh, okay, text is still readable. Anyway, I mean scroll, zoom in.
Yeah, I was just zooming for this because it's very.
But this is actually interesting, I think. Yeah, I feel like when you run, this could be done for reasoning as well. You see, like all the concepts that get reinforced this way when you run essays over all the.
You can do this kind of clustering for sparse encoders activations. Like you don't they doesn't have to be on training.
Yeah.
Why is explicit concept on the top chosen feature clusters? Okay. Problem cluster. Because it is the tab 1 illicit function requests.
Top chosen features, top length. Yes, you can find which. Right. You can find which subset of the data set correspond to the different features that activate, and you can remove the parts of the dataset that activate for the features that you don't want, and you can increase the parts of the dataset that activate for the features that you want.
That's cool.
Also,
yes.
the essays have to be general enough, I guess.
Yeah, I guess this goes back to the kind of method that its main problem is that sparse encoders are not that good. As it's good enough for a lot of things, probably. At least for finding some of the data that is causing problems. At least the most obvious ones are going to show up anyway, probably. But also the same kind of method that you can probably do with better ways of decomposing modeling features. Just keep getting me.
Then they have some math for explaining it away.
I think the only problem if it's if the model learning something is more complicated, right? Because it can be that it's some complicated combinations of things that you don't understand. It's not as straightforward. Just remove the text that is said directly about the thing. Especially in a lot of some in more complicated misalignment or scheming. But this can be useful anyway.
Explicit tilted by reward. Times exponential per concept terms. And you wanna delete the emoji term. So you decompose the tilt to tilting term into concepts. Reward chipping. Use the essays feature activation as an emoji score.
You guys hear me?
Yeah.
So what do you guys think about the cluster, the SAE? Do you think it's a way to try to find more manageable, unit, like sometimes SAE maybe too gather or something?
Sorry, can you repeat to what?
What you guys? I was wondering whether it's common people cluster SAE, like maybe you feed some samples and then you cluster. You check the activation of the, and then you cluster them, and maybe kind of make a connection, between the SAE and what they can represent, or like maybe can manipulate them.
Eh,
I'm not sure if
I
I got your question correctly. Yeah, that the clustering is pretty common. Yeah, or at least the original monosemanticity paper by Anthropic clustered everything.
Oh, wait, right.
yeah.
What do you wanna say, Victor?
I don't know. I think part of the so I think there's a bunch of problems with person encoders, and maybe clustering helps, where a lot of features might actually be the same feature, or related to the manifold stuff. But yeah, still a problem is that even if you cluster, there is some problems where the model, this person encoders are still not necessarily that good. But it probably helps with a lot of stuff. Yeah.
Yeah, I see. So basically, they kind of go from the other end, right? So like you have these human-made examples, and you trying to from this end trying to find some meaningful unit, like a classroom. But maybe they contain a lot of different kind of things. Yeah. Like a convoluted things.
Yeah, a lot of the features are also like essays try to make the features more monosemantic, but in practice, all of them stay still polysemantic
Right.
as well.
Yes.
But it's on a spectrum, so it's still more monosemantic than the base activations, for instance. Also, some
Thank
of
you.
the features are just gibberish that cannot be.
Yeah, that's
Well,
also
The essays don't reconstruct everything, the whole active residual stream. Someone was saying something?
yeah. But there's something like this containment hypothesis with this concept cone thing. Maybe that's helpful for this thought. I put it in the chat.
can you explain that more? Like what the image means?
Is this containment hypothesis?
Yeah.
Maybe it's. I'm not sure if I can explain it right, but I think it's important for why scaling at all is useful, because when you say, okay, we just train something with a certain set and we just can scale it up with our human concepts, then we just are more efficient in this cone, I would say. You know, I think it's more relevant for this type of which training data I have, and can I make this cone denser to the human concepts. Actually, I think it's more practical relevant than theoretically.
Mm.
But
What's
I'm not.
What's that image from, by the way?
I can check it. It was a paper. Give me a minute. I can find it.
Okay, yeah, don't worry.
Yeah.
I'm going to look a bit at the paper. Wait a minute. Mm.
If essays are learning the true structure of the data, they must be able to reconstruct plausible human concepts. I don't think I agree with this point, because humans, like, I believe that it could find structure which isn't plausible human concepts, in the sense humans.
Oh, I guess a
Humans.
counterpoint to that could be that even if it learns that, it could also, like, the human's concepts should be a subset of the structure of the data, but at the same time, I wish I not fully understand what they. I will have to read the actual thing that this is from, to, like, what do they mean by reconstruct the human concepts or whatever. Like, the ontology of the model could be different from the ontology of humans. That's another thing. Like, even if you could still explain the same concepts, they could be, like, the model could be thinking out them in a very different way. But maybe that's still being able to reconstruct human concepts. I don't know. Oh, nice. Thanks for the link. Concept cones.
Yeah.
Yeah, no, I haven't read this paper. I guess I will have to read it, but to understand what's
That
exactly
sounds
talking about.
very interesting.
Yeah, going back to the current paper though. But yeah, thanks. I think that's interesting. Maybe if we don't have other papers, we could read that one if it looks interesting.
It bridges essays and CBMs. What is CBMs exactly? Concept bottleneck models. CBMs provide human definable reference geometries essays can be. Okay, so this is some ground truth of human defined reference geometries, and apparently it tries to find if essays are learning that. That's, I guess, what it means. But I don't think that human defined reference geometries are the perfect ground truth. But maybe there's more to this paper, yeah.
Okay, so
I think we also have empirical evidence for that so far, like the AlphaGo move or the unit distance problem.
Notion related disparity.
Okay, so there's more example.
Yeah, so there's a bunch of details on
paper's
how they do
working
clustering.
assumption that the paper assumes that the concepts are statistically independent.
Validating the
Unsure.
feature considers the position rate of pipeline. We validated the feature by comparing the same.
The reward gap secretly has two parts. The reward
Rank
is the
validated
sum of
interrupt.
log concept classifier scores. Concept. Okay. So when you have the reward and you have a receipt with an emoji, then you can decompose the reward into correctness of a receipt plus emoji. Alright. And because it's a reward, it just sees the combined reward, and so it's reinforcing both helpfulness and emoji. They have the closed form optimum equation there. So the policy is the original policy times e to the reward which is equal to beginning policy times first concept times second concept reward. Why can they? I'm so confused here. Oh, because you have logarithm. So the e just dies. How do you know that the reward is the sum of log concept classifier scores? Why log? Chosen rejected probability ratio gets multiplied by this. I guess because learning is logarithmic, that's why. So it first updates a lot and then updates slowly as you train more and more, I guess.
Anyway, and I could random thing, but I probably maybe we should need to go back through it. I probably do have some questions, not about this one, but about the previous, like the manifold steering paper. I probably have some questions that I could ask the authors on the Slack or whatever. But I'll see later. Like
Yeah.
about, for example, if they
I made a whole thread just for the Mech Interp
finding
announcements.
other things that weren't already on the that weren't
Yeah.
already known.
So I made a whole thread in the Slack Discord. So you can just go in the thread and reply to Lee Sharkey, who replied in the thread. Oh wait, Lee Sharkey. That's that guy. That's the parameter decomposition guy. Who exactly replied to the parameter decomposition paper?
I was thinking more. Yeah. I was thinking not that paper. That one was also interesting.
Yeah,
I feel that one that we will need more reading because there were like 3 papers and they were improving on the next things.
Yeah, I'm gonna show you exactly. It looks like this is the reply that I meant. But since he's from Good Fire, I guess you can ask him literally anything.
Yeah.
Ooh. It's directly good. He's pointing directly to Good Fire channel.
Okay.
Nice. So technically, do I now suddenly have access to the Good Fire channel? Interesting. Okay.
Maybe we could ask them to present one of their papers one of these days. But yeah. Now it's late for these ones.
Yeah, I think if you point, you could get also manifold questions.
In the studies of target attributes. Yeah.
Do you have essay
I
feature
guess
who
curious in
scores
general,
like
but
this?
maybe they don't want to talk about that yet because they're still working with how the whole unsupervised finding of manifolds in model is going.
Alright. You basically take the SAE activations and just put them into the reward and predict how it will change the concepts this way.
Wait, what are you talking about? Don't you take the difference of where is that? Like, don't you just take the difference of activations in the rewarded and not rewarded examples? I thought that was how it worked.
Yeah. Yeah, that's how you get the essay features,
Okay.
I think. Which activations activate there, or which essay features activate there.
So. Uh,
Also, you know what's the equivalent of del for Claude? And I'm seeing it more and more now. Load bearing. Everything is load bearing.
uh-huh. Cloth, everything is a building for cloth.
Yeah. We will delve into the load bearing assumptions now. You're absolutely right. We will delve into the load bearing assumptions.
Okay. Also, Claude has a point. I just asked Claude to summarize the thing, and Claude has a point where they are assuming. Yeah, that this is what I was saying. This kind of you just remove some concept from the data and that's it, and it's like more complicated, like how the rewards are connected. I think they do. They mention this somewhere in the limitations.
Wait, there's a gauge word. I just noticed gauge. Where they say gauge? Gauge. Aw. They don't mean gauge theory. I'm disappointed. They mean gauge in the normal human sense. My disappointment is immeasurable. My days ruined. Okay.
That reminds me of on the Ghost Court, people were saying, were telling Leo, someone was saying that they think they found some way of making category theory useful.
I'm skeptical, but prove me
Yeah.
wrong. Yes.
I think when they were just miming.
Oh, never mind.
Probably, I don't know. Maybe they weren't. Who knows?
Yeah. There was some paper recently, but that wasn't in the context of Mech Interp. That was in the they formalized scientific method somehow in category theory and
I
said
mean,
and put it into
there was
AI
that paper by
scientists
Neil,
referentially.
right?
You mean universality?
Yes.
That's not category theory. That's representation theory.
No. Okay, then it's useless.
But
day.
both category theory and representation theory share the property of being like meta mathematics, basically, you could say. But the representation theory is less general because you do linear algebra basically to work with abstract structures.
Is category theory just too general and abstract to be useful for anything?
Well, it is useful for abstract math. But yeah, in terms of empirical science, such as deep learning, that's kind of an issue, yeah. I'm not convinced there yet. But maybe that will change. I think it's potentially useful, it's just so early, basically. I maybe listened too much to the category theory people, just move the timelines.
The world shaping by aggregating. You just need to wait until Fable 6. You can just ask, find ways to relate category theory.
Yeah, like category theory is like linguistics of mathematics, and I believe that itself can be extremely useful to.
I mean, have you actually tried asking the current models how trying to find you relationships about things where category theory is useful in Mech Interp?
You can just categorify everything, which is just express it in the categorical language, but yeah, I'm not. But
I mean,
I
when it's actually useful.
What's the use? Yeah. This is what they did in categorical deep learning. They categorify deep learning basically. Then derive some new architecture. Is it actually
useful though?
They derive some new architecture apparently, but like the architecture is so random, and like usually you derive architecture because you wanna train on some data. You like some inductive bias there, like because it's so abstract in the highlands. I think it's not really motivated by anything. I don't know. I'm not sure. Maybe I'm throwing it. I wanna get into it one day. Too much things, too many berries everywhere to eat.
Yeah.
This is the load-bearing assumption. Let's delve into the load-bearing tapestry. You're absolutely right.
Yeah, so I think it's all here. So if you training, if you they're talking about here out, I think I was thinking out, and Claude also mentioned that. So the problem is if you naively just think, okay, so I don't want the model to misbehave in this way, so I'll just find the things that activate the the misalignment feature or whatever. You are not. That doesn't always work. That's like a more complicated thing that uses multiple features. Style has a hierarchy, style formatting, contains markdown formatting, contains turn tables, conditional rules, bold text, emojis, local activities. Yeah.
But it's cool that you can find the features of significance in a sense.
And so
But it's
it's
interesting
like
how you go ahead.
so it's like they don't. I don't think they show the how to control the damage if you change something. What may happen for the related things?
Yeah, I guess they're here talking about how their current kind of method doesn't necessarily tell you, like, it's you need to figure out how the features are related to not to be able to change only some things without changing others. They talk about penalize apparent content while preserving the child. Preferring very simple multi-resolution concept. Like, to some extent, some of the parts of the encoder features are already multi-resolution, but there are some problems with that, and it's kind of like current part encoders. I think I kind of a mess of different levels of abstraction of like features.
I changed my mic setting. Tell me if I'm not cutting off or something.
Okay,
Am I too loud now?
you better slightly louder for a bit, but I don't know. Keep talking.
Before
Okay.
loud voice, now it's pretty good now.
This is probably too loud. Is my voice not too low right now?
I can hear you,
I
so
think it's
I
pretty
can
good.
hear you.
Yes.
Okay,
okay.
it's not too
I
low, too high.
well.
Okay.
Also, Usagi also here. I didn't
I
notice
wanna
you
see
joining.
the load bearing assumption. I'm gonna kill myself if I hear that one more time. From the Bigelow et al. Like this whole paper is assuming this, and so you have to this assumption must be true. So I would be happy to understand it. Why you can just take the essay feature as like score and just compute the reward from the concepts.
Wait, I don't think
Like
they
Logot's estimate.
do that, right? I think they just take the. Don't they just take the concepts that activate more on the less rewarded ones and like take the difference with the ones that activate on the more rewarded trajectories, and that's it?
Wait, let me find the where the activation of an SAE feature, the projection onto a steering vector,
I mean,
or
I
the
feel like
logit of a linear probe can all be interpreted as estimating the logots that an output expresses a concept. Cited Bigladov in the reward shaping section.
I guess so. So
If the
this
score,
paper is about the thing. It's a bit about the thing on the blog post, but most of it is more this idea of like this framing of talking about behaviors as like they do this thing talking about classifiers, but it's just they're trying to they're thinking of which feels like a simplification, but like they're thinking of the behavior of the model as have some product or like so you have some series of classifiers for different features and they activate for some things and the reward increases the one that's activated for that activated for some rewarded text and not for the not rewarded more than for the for the rewarded text.
Like, it makes sense if the... yeah, I think it makes sense. But it's interesting that it's logarithmic. Like, you can see how the score of the feature...
What is the logarithmic stuff that you...
I posted in the chat the section, the reward section. And here's the relationship. It's interesting that it's logarithmic.
Okay, but this is for reward shaping, not for the sports encoder
Yeah.
stuff. Or like,
Yeah.
okay, there's still sports encoders, but it's like a different method that the other thing I was thinking of. Okay.
It's interesting that there's this logarithmic relationship between the scores from the sparse autoencoders and how it corresponds to the reward logarithmically. Or some strength delta.
Isn't it just because the way the reward works and like how the logits gets softmax later and add to one and then
Maybe, yeah.
This is controlled at a local level or more like a... Do they have anything?
Wait, it's a reward. So there's logarithm after. Okay, maybe, yeah. It's interesting anyway that there's this relationship. I guess it makes sense intuitively. I want to read the paper how exactly they derive it though. To be more precise. So you remove the...
So this reward shaping thing is changing the reward with the sparse autoencoder activations.
Yeah.
Well, what they
basically.
do it, they add it logarithmically because, I think it makes sense to do it logarithmically so that you don't, like a single very high activation doesn't break the thing. Yeah, but the logarithmic thing there is the score, right? It's just that they are putting it on the, like as part of the reward. Like as in the reward function.
Also noticing this is maybe the first AI paper that I not rerouted to Opus 4.8 while chatting about it.
I have been rerouted to Opus permanently by not having more Fable tokens.
Okay, I see. Yeah. Like
I'm not going to pay the API prices, so I'm
yeah, it's gonna be for everyone tomorrow.
Now it's too late, but I was tempted to just pay $80, like when they had, like pay the expensive subscription just this month, just for having more Fable. But
today, Tim from MLST spent $250 on a single Fable prompt.
What for?
I don't know what exactly he did. But a lot of sub-agents. That's what I know.
You guys are talking about using Fable?
Yeah. Now it's broadly accessible now, if you mean that.
Yeah, I haven't used it too much. I'm happy that the government at least tried to regulate, even though the movie.
Well, if you don't pay $100 per month, you will probably not be really able to use it, to be honest. Or just one prompt and then you're done.
No. I'm just happy the U.S. government did regulation in any form.
I mean, I think it would be better if they did it in any sensible way that is not just randomly deciding to do it one day, you know?
But this shows the possibility of using the government.
Yeah, that's
for
true.
regulation.
I think it's definitely
I'm
better if
saying
they
like if
never
this
regulate
failed, it
anything.
would be a lot worse. Like even though the motives are bad, the fact this worked is what I'm happy about.
Yeah, I guess that's. No, that's from yes. On the other
Yeah.
hand, that's a very low bar for the which it is surprising they clear it, but that's because they are kind of terrible at this.
But you need a low bar for regulation in the
Yeah.
The logarithm is there because the Kyle divergence part of the reward is logarithmic directly. That's why. Okay. That makes sense. Otherwise, it would feel kind of random. But yeah, this makes sense. Okay. Sure. So you do that. All right. All right. So you take the logarithm. Then you subtract the logarithm of the emoji if you want to remove emoji. And you just give a logarithm helpfulness. So the policy is tilted by.
This is neating that it's this kind of thing is a way that more making their work can be useful for things that the labs will care about and use, and hopefully we with better methods you could try to make the mail models more aligned or something. I don't know if that will generalize in that maybe the actual more scary things like models scheming later because they have some goal over long time steps and too complicated planning might not be easy to locate to some specific feature. It might be like just the whole reasoning of the model, and this lets you remove bad things from the training data. I guess you could also use it to try to add good things to the training data, to try to find text that activates some feature you want more of. But yeah, I feel like you still just need to actually understand how the model works and what you are doing. Otherwise, just kind of blindly.
I guess you could also combine it with the parameter decomposition one. But yeah, all these methods are not perfect yet. Well, if they will ever be, because this is machine learning.
Yeah, but I still feel like all of the methods are still kind of blindly changing stuff inside the model based on what seems to be like some feature that have you more or less figure out vaguely that they are about some topic based on what they seem to activate on, but you don't really know, like on the level of structure of the internal computation of the model, what it's doing. Right? It's like you had some program that you don't understand and you are changing random variables or having only a vague understanding of what each variable does based on from trying things out.
I love alchemy. Ablate everything and
But
see
it's
what
at
works.
least definitely better than blindly doing it based on output, though.
Yeah, so that's why they have this pipeline available. Everyone can do that. Try out.
Yeah,
Hmm.
that's nice. That's I think it's definitely better than just blindly trying to make your data from the by guessing and like seeing that the model did something you don't like, and then you try to figure out manually like what was it. You have to read the whole data or something, and this way you can just find something that activates the whatever feature and remove it. But it still just has a bunch of ways to go into you actually being able to edit the models however you want. Oh, you have background noise. You should mute when you're not talking. I mean
I hear some children.
yeah. Thanks. Anyway, so what I was saying. Oh, you want to say something? You can. Well.
No, I was just apologizing for being unmuted when I joined. Thank you.
Anyway, that does I kind of I'm kind of getting something and going all around. Is there people? Is there any part of the people want to me to go to? Because yeah, I kind of lost right now.
I'm now finishing the example.
I guess yeah, but we can keep going to the math. I guess I could look at this part.
I'm still disappointed that Gauge doesn't refer to Gauge theory.
We'll get some Gauge theory later at some point.
Yeah, there is some Gauge theories of deep learning, I think. Yeah, like I learned Gauge theory before I learned what the word Gauge means outside of it. It means also like something with measurement, but in physics, the word lost all meaning, the original meaning. It doesn't mean anything with a measurement anymore. Like, yeah, that's the original word. It was first taken from the original human meaning, and it got just shaped into completely something else. Yeah.
So here they have like this about like the different methods how they change different things, which is interesting, I guess.
But didn't they say with the style modulation they mostly just use GPT 4.1 mini, or is it just they were using other things for the data prediction?
Oh no, this is like I guess it's the same model, but it's different methods because so the blog post is just about this thing where they find the sparse encoders and take the data and all that. Well, no, actually, I'm wrong. So they do this data filtering thing, and then they do a bunch of different methods to try to change the data. Which one thing is just doing? Yeah, I think I was understanding the problem wrong.
So
one
this
thing
is basically just look at data, use a bunch of interp methods to inefficiently filter the data. This feels very expensive and not practical.
It's look at data, use sparse encoders or some other way specifically, and do you cluster them, and then you either do data filtering, do inoculation prompting, activation steering, or reward shaping.
Yes, but this does not feel very cost effective. I just don't think this will be implemented on like any frontier model or any like
Oh, you mean because it will be too expensive to run as
it's not I just think this
entire
method's not
data?
practical. This is basically the idea of like we'd use full interp and we run transcoders and everything. We'll have to load transcoders onto every single model response.
Yeah, no, but I mean, I think if you I think that's a fair point. But if you are doing reinforcement learning, fine tuning, if you are doing reinforcement learning, you could do you could do it for it could be a smaller data set that you're just doing reinforcement learning on, or you could do it for some subset of the for some samples of each data set and figure out if some data set is doing the thing. But I do see how if you have a very big, if you want to train a frontier model, you want to do full you want to find all of the things, you will need to run a sparse encoder on the model on the entire data, and maybe that's just not.
Yes, and also they need to probably test if it's cross model, because let's say you're using the sparse autoencoders on like Claude, I don't know, like Fable 1, and then you're using this on the data. Do we know if we're doing another major version of Claude that's not Fable, like some other base model?
They are very weakly cross model. Like you
Yeah,
have to
they're
train
very
FAEs
weak
on
cross
multiple models.
models. So this data filtering method basically will become useless the moment you
Oh
get to
no,
the
but I think you are mixing two things here, though. SAEs are
mix. Yeah.
very weakly cross model, but the actual SAE applying to the model, right? But that doesn't mean that the different models have completely different features. And
Yes,
like
the
for
features themselves exist, but like maybe
yeah, but for the data filtering, you only need to know the features, right? If you're trying to figure out why your modeling is talking about goblins, you just need to know if it's a goblin feature. So you could run a smaller model with a sparse encoder, find out which text which text activates the goblin feature, and that maybe
yeah.
generalizes to which
But
text.
like I'm saying this won't be good for like scaling research because like let's say a model like Taki that only has 1980s like data. Taki has no concept of the internet, no internet feature. So if we're training a model that has the concept of internet later on, like how do we like filter that out? Well, before the model
But
has internet as a concept.
okay, but so is your idea that it doesn't you cannot use an older model that there is some new concept that only the newer models have that the smaller models didn't have, and you are not going to find out on the data from this kind of filtering if you are using the small model.
I
I
just
think
understood part of the math.
So I'm saying like let's say like there's some A behavior that's dangerous and we don't know if we think models can't do it yet. If we try we can't prevent it because we have no way to filter that behavior.
yeah, I think that makes sense. I mean, I think also from behavior you are not going to necessarily going to be able to filter it with this kind of method because the behavior might be depending on a lot of different features and not there might not be a single I don't know scheming feature or something. Or they might be, but might not be enough to remove it. All of the text that activates it from the like removing text that about the skimming from the data might not prevent models from skimming because they might figure out the skimming from first principles or something when they get better at reasoning. But yeah, I still think this method is better than useless. Like it's still useful. I do agree this doesn't I don't know solve a mirror or anything like that.
Yeah,
But
this feels more like this could help benchmark max, but this does not seem like if you're trying to build a next model, it will prevent a behavior.
I think if you are trying to build a next model, you might prevent some things, or like you might
Yes, you'll prevent but
you
it
might
doesn't fix.
filter some
Yeah.
things. Like I don't know for a lot of things you don't figure out later, but you could look at your data. Maybe there is some like you probably prevent some of the most obvious things where there is some data that just has some bad behavior directly, and you catch that. Or maybe the models are like straight up lying in some text, and they activate. Another thing is okay. This will be more expensive, so maybe it's not trackable. But you could use the model itself to like you can use the pre-trained model to filter the fine-tuning data, right? I was thinking of using smaller models because that will be less expensive, but you can. I mean, here what they're doing is using the actual model just on the pre-trained model, so it will still have the same features unless it learns the features doing reinforcement learning. Although there is a lot of I think they will just a lot there's people there's some disagreement about that, but yeah. At the same time, yeah, I mean definitely you don't cut. They also do have on the discussion section they have a bit about how the models don't necessarily like how this doesn't work for everything. about and how they need to figure out more like their relationships within features and all that. But yeah, like in the end, I think we actually just need to fully understand or like understand at least on a high level of abstraction how the models work in more detail than just playing around with feature alchemy. But I do think this is probably useful, and you can find some problems with the data that and yeah, I wonder maybe you can catch the model lying by seeing that it's activating some lying feature, and you figure out something about what kind of examples make it lie, and you remove those. I don't know. Like it feels things like lying should be a feature of all of the models, not some new thing. But yeah, I don't know. Maybe it's just not located to a single feature, because that's related to also the liar's bench result stuff, where the classifiers in one thing doesn't generalize to the other examples. But yeah.
Yeah, when I did the secret agenda paper, our results seemed to indicate that there wasn't one feature identifiable with SAEs for deception or model lying in game environments, but rather like it was distributed across things, and we had to do a TSNE in order to actually have those be reconstructable from the features. So and ablations also seem to break things like identity. So I would say that my theory is that they are more distributed than just like the singular features in traditional SAEs.
I guess at the same time, I could imagine that maybe you find some better method and you could still apply this kind of thing. That you could do data filtering, but with whatever better method that the SAEs people come out with. Uh, so, like maybe you could figure out something with manifold, maybe something else. And it still works. But yeah, there are some problems with a lot of things we care about might not be located in some specific feature or cluster of features.
Yeah, that also gets into like interpreting features or interpreting a consortium of features and the manifold or like the different geometries that Goodfire's been finding. I think there's probably something there.
Yeah. Yeah, but at the same time, if it will be easy to if I don't know, tomorrow they figure out, I don't know, some nice method to find, I don't know, the lies manifold or something, or there is some way of figure out the geometry of being able to tell when the model is lying or not. You can you don't need to change much on this kind of method where you just look at the training data that activates the lies, and that makes the model lie, and fix that. So like I think the concept of this kind of pipeline is still nice. Even if like the weakness, one of the main weaknesses maybe that currently the way we have to figure out features, the sparse coders are just not very good.
Yeah, or even just getting more granular with our diagnosis, right? Like lying, but also like that might be just such a broad concept. We as humans say like, oh, lying, that feels specific to us. But like when you get into the contextual situations that lying arises, then it might actually just need more granular diagnosis.
Yeah, I think that's related to in the liar's bench paper the other day, that like they have different data sets, and the different data sets have like different reasons for lying, and I think that like the activations on the models are like very different between each of them. At the same time, I think as models get better, you might still like if there is something that humans will say is lying going on, I will expect the model to track that, right? Like the model is trained on the internet, and the internet has like humans with humans concepts of like what lying is, and model has to be able to answer questions like, is this lying? Given some example, and so there has to be some way for the model to represent that something is lying in the ways humans will mean it somewhere. Even if the ontology of the model more that it uses for other stuff is not necessarily that.
Yeah, I think that also there's just the potential that our descriptions of lying are meaningfully different from the context of models perpetrating lying. So, like, I do think, for example, the Goodfire SAE API that they put up, from my poking around and also that secret agenda paper and stuff, there was definitely like the presence of labeled as deception related features or lying related features, right? But then is there features that actually represent when like the internal state of a model would lead it to lie? Like I think that might actually be also kind of, to dig into what you were saying, a differentiator there of, yeah, we probably do have ways of talking about deception or lying that the models have learned and are cleanly identifiable. But then we have this whole messier, more relevant, more important alignment space of like model behavior that might be more nuanced.
Yeah. Yeah, I guess the model might be behaving in ways that are lying and not necessarily thinking of humans will consider this lying all of the time that is doing that.
Yeah, exactly.
Yeah.
Or maybe it doesn't even realize it's lying in the same sense, and then maybe there's just a late layer circuit that throws in something to fill the gap that it's withholding, or some other process going on there. And to us, that would look like lying because we'd see the wrong statement, but maybe it's just withholding the right statement, and then the internal representations would be about like withholding the right statement and not necessarily an intention of deception.
Yeah, or like the model works
Mm.
more like a bunch of personas that have different beliefs, and like some process like in some sense puts in front some persona that actually believes the thing it's saying for strategic reasons. So which is kind of different from lying.
Right, like a subspace of the model thinks that it is truthful, even if the larger model might not have that perspective across it. But then that gets just activated internally and becomes like the dominant output mode. That makes sense.
Yeah,
That
I
would be
guess
really hard to track.
we just need to. In the end, we kind of just need to actually understand what's going on inside of models instead of just looking at some parts of them and they seem like they are features and they seem like they activate on these examples, but we don't really know how the whole thing works, like a lot of these things seem very hard to disentangle. You could potentially disentangle with a lot of evidence for like when the source encoder features or not. But yeah, it seems pretty hard. It's probably better to just actually understand at some more like circuit level or something how the mechanism works, like what the features do exactly. Like, are they like when you find some live feature, is it actually about the like does the model work more like the way I said earlier about having different agents or something? Does you find a feature that tracks some specific agents believe are supposed to like some like what the text prediction was predicting will happen or something? I don't know. As kind of we need a lot more basic science of LLMs, I guess.
Basic science, yes.
I think so. the convergence of like circuit tracing and like the natural language autoencoder type of angles like seem to be totally opposite approaches, but I feel like there's some sort of convergence there in like the internal geometries that Goodfire's been finding, that we could do the equivalent of like an ablation study for, or someone could essentially do an equivalent of an ablation study to take out those like sub-personas that you're describing and see what ultimately happens there, if it disrupts that model behavior, disrupts like the internal representations. But I haven't seen many like ablation and SAE or NLA type combo studies.
I mean, I think there are some stuff with people trying to find circuits by doing, causal interventions on features and all that. I think like there is we actually had like sparse encoders are not that good. Like we actually had some better method that, in some sense, divided the model on the true features, whatever that means. Or like individually minimum features. You could do better ablations and just figure out how the models work better in terms of doing different ablations and see what happens. And like see which parts are culturally relevant for different outputs and all that. And there was a bunch of methods to do this, and I feel like a big problem of those methods is not that the ablation part, is the actual sparse encoders parts where the sparse encoders are not actually, they are kind of polysemantic. The features they are not that good at disentangling the whole thing and getting the right. Especially if it turns out the something more like the manifold stuff is going on. So in the end, we don't have the right things to ablate. So you ablate as part of the encoder feature, and you're kind of just breaking the model in weird ways. So no matter how much you do, try to do conditional ablations and try to figure things out, you are not going to learn what the correct, like you are, for example, not going to learn which parts of the model matter for something, because you are kind of actually just breaking the model in weird ways. To the extent that there's parts of the coders don't capture the right thing, which is actually kind of high, because they're getting better. Like when people are doing transcoders or whatever, and like whatever the new version are, and they keep adding things, but we're still not on the point where it's mostly the person code are mostly just good reconstructions of that actually divide things in like features. And I think it's also kind of hard to think about what exactly does it mean for something to be a true feature inside the model or whatever. But yeah.
Yeah, also because the labeling processes themselves are in kind of a polysemantic language space, that there's inherently ambiguity, and we have to reapply them back down into from attempted monosemanticity, which we don't even have totally nailed down yet, to trying to then apply it back to a model in activation, right? Whether we're steering or ablating or whatever, we're still looking at its outputs, and then its outputs involve that or require that polysemanticity. Yeah, that's kind of a trap.
Yeah, I think a lot. For example, I feel like a lot of people in the field, like Neil, have kind of, not exactly, but kind of giving up on actually figuring out how the models work, and just trying to find some practical hacky thing that we can use for alignment in practice without having
Join
to
the-
fully reverse engineer the
Join
model.
Join the black box alchemy, right?
The non-mechanistic
Never.
non-interpretability.
Yeah.
uh,
Okay, I was so confused about the reward shaping. Apparently, according to Claude, I just figured out another method. If Claude isn't suffocating me, that should work. But I'm still confused about the reward shaping. I'm gonna try to look more. What exactly is happening?
I see it's Isn't it like adding a term for the concept
mean-
you don't want?
Like if you have, I'm not sure if I still understand it. Maybe I'm just understanding wrongly. If you have like, I don't know, correct helpful recipe of cake and a lot of emojis, then you like, because it has emojis, you slightly make lower reward because you remove a bit of the reward every time there is like emojis, but you still get a positive reward. So and still the positive reward applies to the emojis as well, even if it's lower. So you lower the emojis, but you don't completely remove any reinforcement of the emojis.
Oh yeah, but you like there are some.
I
but
guess it works
here-
then.
Here I think it works, right? Because there will be some examples without emojis, but with correct recipes of cake that get higher reward.
Yeah. No. Yeah. No. Yeah. No. Yeah. True.
No, Usagi, no, this is a different
True.
thing. So, like the delta matrix, as I understand it, it's on the. Oh no, I'm not sure.
Yeah,
I
you're
think-
right. But you don't remove it. So maybe you can remove it by masking the emoji tokens. But this only works if that's the method I came up with.
Okay, I think maybe it does come from the delta matrix. I responded to Charlie's question on the thing, but I'm not sure.
Uh,
Uh,
like this is the issue with rewards. They are sparse and they are single scalar. So when you reinforce anything, you reinforce like the whole thing, even if it's lower reinforcement. You still reinforce the whole thing. So I believe this is a fundamental issue of
But-
reinforcement learning.
but if
Sparse
you,
rewards.
but if you
Single scalar.
you still get more reward on the cake ones, and the yeah. So I can see, and like if you are
Mhm.
doing so, but on the reward function, right? You are getting the. I guess that goes back to the question that you have asked, Alex. That's how you are you getting the cake, because if you are getting the cake score from doing something, from the sports encoder, right? And you are back propagating through it. You are doing something like there is a direct negative term that goes through the emoji feature, right? But I'm not sure. I'm not sure I understand how the reward shaping works now that you actually make me think about it.
You have. So you my understanding currently, which might be wrong. I might just write it into Claude and tell me if I'm wrong. That wait, my music stops. Let me enable. Good. You have positive pairs that you wanna reinforce. You run them through the SAEs. Anytime there's a positive concept for, then you decompose the reward into the different concepts. And you remove the concepts which are which you don't want, basically, in the reward. So the whole positive reward is slightly lower because you remove the concept term, and so you still reinforce the whole thing with the emoji, but less.
Also, yeah,
So-
no, the Claude says it's not back propagating through the reward.
Say again?
Claude said it's not back propagating through the sports encoders, like I was wondering.
No, essays stay the same. Those are just used to get the reward, and then you backpropagate. Wait, Yeah, then you backpropagate through the original model, I think. I'm gonna write this. So it works like this.
Also,
It
yeah,
works like this.
apparently no,
You-
the reward shaping offset is not the same as the delta matrix.
You take the data set, and the parts that part that you want to positively reinforce. You run the data through the SAEs, get the concept strengths, and subtract the concepts that you don't want from the reward by the SAE activations to reward lock correspondence. This on average downweights this on average reinforces emojis less, but it still does, since they still have positive reward, while helpfulness stays reinforced a lot. This is my grammar saying. Let's see if it's wrong. Concept strength from the SAE equations.
Also, the Claude claims that they show that the thing you are saying is not like assuming that the concept, like the concept is cleanly separable from the thing you do with the reinforcement thing. You still get you do make it less like it modulates it down.
Yeah, like you still
In
get
appendix
positive
A.
reward, but less every time there's the concept that you want. But it's still positive, therefore it's still reinforced. Another option is data filtering, where you just remove all the data with the emoji. And that just gets rid of all the emojis. But that also gets rid of the correct recipe. But you still have other correct recipe without the emojis, or helpfulness, or whatever. It's the other concept. That's my understanding. Verdict. I am right. I am false about something. Wait. So it's not completely right, okay. If Claude is not hallucinating. I didn't understand what I mean. Wait. Okay. I might be misunderstanding some part of
Yeah, I think
DPO, maybe.
I think you are also.
I think I may be misunderstanding some part of DPO. Let's see.
Yeah, that's also my impression from also asking Claude about this. I like reading there.
Let's see where I'm wrong. Time to figure out.
By the way, does anyone else have any other take on the paper or something? So yeah, I'm kind of getting this started and going all around the paper. Maybe I should focus on some part, but I don't know.
Like, DPO should be just training on fixed dataset preference pairs using classification logistic laws. So it's not even reinforcement learning. Well, it's kinda is because you generate, I don't know, depends. It's like
Also, oh, by the way, but related to the thing you were talking about, it's still true that reward shaping works better for amplifying behavior than for removing it.
Mhm.
But my understanding is that
I'm not
Claude
surprised
claims that ideally you could completely make the model not care about the behavior if it was like clearly separated in some response to encoder feature and not correlated with anything else or something like that.
Yeah,
But
that's the load-bearing assumption. the separatedness.
you still make it less reinforced, but I think it's easier to make it more reinforced.
Yeah, like definitely. You just add.
Increase
If you
the
wanna
reward.
remove that's harder. Correct observation wrong mechanism predicts the wrong end state. Okay. Let me see. I doesn't understand what I mean by the original. Wait, let me see. So DPO trains on a fixed data set of preference pairs using a simple classification style logistic loss. I have to explicitly say that if it's correct. Otherwise, Claude will roast me. Well, it will roast me anyway. Let's see.
You observe the steering vector if you can reduce the model steering user activation of steering intervention. Where was from the loss. In particular, implementation performs steering on just response. However, it is trying to teach the model the opposite was sent to amplify. It's possible the model finds a wider on the intervention. So it is we can stay intervening the rejected response for a prompt. They talk about the steering here about the steering as explaining away, but I think this is the same thing as the method on there was which paper? I think it was the one of the steering papers. I don't remember the name, where they train the model by steering and then remove the steering. And here they are doing the same thing, but with the framing that this is trying to make the steering explain away the like explain why the model is behaving in the way they don't want.
I didn't pay much attention. Or can you say again?
Okay, so it's here. So they have this more general framework of you make the model do less of a thing by giving it some reason why it's doing the thing on some example that gets rewarded that doesn't happen in other contexts, right? And they in this and they are doing here something that they think about this way that I think it's interesting because it was already on a different steering paper that I don't know if they realize, which is train the model with steering against the thing you want. Like you train the model while steering it to write emojis with the cake example, right? So then on deployment you remove the emojis steering, so you have a model that only outputs cake examples without emojis. I don't know if you
You
understand.
train the model while having the steering vector for emojis.
Yes.
Then you remove it. Okay.
Yes. So then the model doesn't learn, like the model just learns the output the cake because it was like the emojis were in some sense already done by the steering, so it doesn't have to modify its weights to be, to output emojis. So it doesn't. So when you remove the steering, it does more emojis, like it doesn't do emojis. And this was already, but framing a very different way on one of the steering papers. I don't remember the name.
I see, okay.
I might mention this on Slack, like it wasn't already. If it's not already on the appendix.
Yeah, I'm misunderstanding some parts about DPO. That's why it doesn't make more sense what I meant. It doesn't see absolutely. I'm still thinking reinforcement learning. This is not reinforcement learning.
I mean, it's a subset of reinforcement learning, right?
Technically, no.
Well,
Well, you have a reward, but you just train a fixed data set of preferred pairs using classification. Okay, maybe. And you have a reward.
Don't you just have still have a reward function and you are training on that
Yeah.
one?
Yeah, you do.
Reinforcement learning.
Yes.
Uh,
You still maximize the reward. But you don't SEM from the policy during training. There's no rollouts, no exploration, no policy grains, no value functions, no reward model. It's
still, then it's still reinforcement learning. In fact, it's more reinforcement learning than the other stuff, I would say.
It's like supervised contrastive learning. But you have a reward. You're maximizing a reward.
It's a true reinforcement
Subject
learning.
to scale, constraint, and so on. It's such a weird reinforcement learning. I'm not used to this. It's just gutted everything.
I mean, it's not just. I mean, it seems to me that it's just the simplest way, right? If it's just you train on the reward directly.
Yeah. You just do classification of preference pairs.
What
So-
do you do with the preference pair, though?
That's what I'm not figuring out, actually. I think
Okay.
that's where I had it wrong. Okay, so let's say a recipe for a cake, or how do you boil an egg? So how you boil an egg correctly, emojis is one response. You boil an egg correctly without emojis is another response, and then you have incorrect recipe for boiling an egg.
Yeah.
So yeah,
And you reward
first
the
is
correct ones, let's say.
yeah. So first is helpful. It has emoji. Second is helpful. It doesn't have emojis. Another is not helpful, and it has no emojis. So you reward those first two, yeah.
But how does
Wait.
the training work? Do you just train on the correct ones, or do you just train on all of them with the
Yeah.
common score, or do you do something else that involves both?
In this example, you should just train on both. You should, but you also should
And you like what is the
lower the
reward
reward
function?
for the emoji one, no? I'm a bit confused here, wait.
I think I'm just going to ask Claude to explain the PO.
Yeah. Like you have preference pairs and you just do logistic classification loss, like for a classifier.
Okay.
That's
So your
TPO.
data is humans prefer this one or the other, and you transform that in a number, and then you train all of them, but doing just reinforcement learning on the reward function of like this that you get from which ones are more preferred or less preferred. Or like
You give positive
classify
reward
them
to
on
what you
being more
prefer.
preferred or something. Yeah.
Yeah. You reinforce what is preferred. That's it.
Okay. And
Correct the reward.
in the end, you just basically have some score for each
Yeah.
data point of how much it's preferred than the others. And
You just have a giant data set of preference pairs and then you do classification, you positive reward for those that are preferred. No reward model, no policy, no rollouts, nothing.
Okay.
As far as I understand.
Okay, so it's not the most simple possible thing, because the most simple possible thing will be you just have some score for each. But yeah, I guess this one is easier for humans to actually
For each?
score. Yeah, just make the humans put a score from, I don't know, 0 to 1 or something. But yeah, I guess asking for preference pair is probably better.
This is like score 1 and 0, technically. A special case of what you said.
Inoculation protein. Oh, okay.
I think.
So
I think I'm still misunderstanding it though. Wait. Let me see. I think I'm getting to the issue that I'm misunderstanding.
I think they probably are
Like,
leaking the right paper. Okay, you can steer in favor of the model on the generation part, so it generates more examples of the thing you like. The way they use steering. It's mean that they do this and then on the end they decide realize it didn't work and switch to the other thing.
oh. Why is raw 2? Ah. Oh,
Okay, according to Cloud32 site persona vectors,
what?
which is where the explaining away the stealing thing.
Because it's. Oh, okay, I see. The reward is just collect all the different concepts together, so it's same. Okay.
I think something nice about this kind of thing is that if it kind of works, I mean, if it's not that good, right? If it does something useful, maybe this leads to some labs using like some more people even on the open source space using this kind of pipeline to improve models, and then basically this will be an incentive for all of those people to work on like a economic incentive for people to try to make sparse encoders and make it better.
Yeah. Wait, there is no reward actually. Because the reward is baked into how the dataset is created. But the DPO itself doesn't care about the reward at all. It's just trained on the preference dataset. Ah!
But it's still a reward, right? Isn't it still like the classification of the based on the dataset?
Well,
think
then
you're
that's
wrong.
just that's just the classification. Do you call a MNIST neural network classifier a reinforcement learning thing?
I mean,
Wait,
you
I just
can. I mean, I think it's kind of arbitrary what's reinforcement learning and what's not.
By the way, there's a paper that says pre-training reinforcement learning where they cast next token prediction. Like, correct next token prediction is a reward. So I am confused.
I think it's arbitrary in that, like, okay, so you have some number and you want to maximize that number or minimize that number, whether this is error or some reward, and like whether you call it reinforcement learning, it's a bit about semantics.
We have decomposed the meaning of reinforcement learning so much that it doesn't mean anything anymore. Great. Like, see this paper, by the way. They like, if you think about it, like, if
I
the
think at
cross
least
entropy loss, like, the reward is just getting close to the target to the train data distribution. That's just the reward. But in reinforcement learning, you also like have a bit more things. So cross entropy, part of it is the reward of being close to the original training data distribution, and in reinforcement learning, you just replace that part and you just put their arbitrary reward. Technically, the reinforcement learning is more general then.
You could also say that, I don't know, pre-training an LLM is classification on dictionary size set of classes.
I think that's correct.
But it's kind of, I feel like it kind of arbitrary also stuff like where you call something supervised versus unsupervised, kind of bias based out the semantics of what the number. But in the end, it's all like numbers on data set.
But I care about it here because they are talking about decomposing the reward using the concepts. But if there is no reward, then what the fuck is happening? Wait.
But there is still, like, okay, so you still have a number for each sentence
Concept.
where you are
Yeah.
trying to make the number higher, right?
Yeah. Yes. Well, you just have the preference data set and you just do the classification thing. I guess you can. Yeah, I guess you can just lower it. Huh. Okay, let me see. I'm so fucking. I just wanna see it written down in math.
So I think
That will be
even
better.
here
Words
you
are terrible. I just wanna see math. I hate word. This is why I'm so focused on math, because words are so ambiguous and
Usagi
yeah.
is saying that reward is 1 or 0 and policy update is just supervised fine tuning.
Yeah. But they remove, like in the reward shaping, they lower the reward by subtracting the concepts. So reward and you say
Have you
reward is
tried asking that
1.
to asking Claude that? Just tell Claude I'm confusing the reward I remember the function. Maybe let's
Equation posits that the reward decomposes into sum of concept level log classifier scores. So you have a classifier for the various concepts. Let's say helpfulness plus emoji plus refusal, etc. And the concepts are statistically independent. Sure. That's a hypothesis about the structure of the preference data. Rewards, not effect. And then separately, a safe feature activations approximates those terms, sure. Using the logarithmic map. Sure. Two-stack approximations. Reward is approximately sum of concept scores, and concept score is approximately feature activations. Yeah, sure. The reward is, there is no reward network anywhere in DPO, and the reward is implicit. That's what I was pointing to. Induced by the policy reference likelihood ratio. Nothing in the training stack ever sums SAE activations to produce it. Then how do you do reward shaping then? The SAE enters only a lens and a scalpel.
They are taking the taking the score for the SAE and remove the adding as a like
But
making
there
that
is
less.
nothing in the training stack that sums the
There's no
SAE
GitHub repo for this.
activations. I guess you can, yeah, this is, you don't construct it, but you can remove it from the origin. Okay. Run the data through SAE, test which features are chosen leaning, and treat each significant one as a hypothesis. This concept is a term in the implicit reward. For the 1 or 2 terms you decided you don't want, subtract the concept from there, from the margin. Everything you didn't name stays in the implicit reward untouched. Yes. Operative feature isn't the reward. Is some of features reward opaque implicit object model probed by the feature by feature.
Yeah, so I guess a big thing they are trying to do on this paper, by the way, is like a lot of the methods already existed. They are just trying to do this kind of put it all on this kind of Bayesian, like this kind of framework about behavior being about like the being like a mix of classifiers of different features, which kind of seems like oversimplification, but I guess makes sense. And on that framing, they try to frame all of the different, all of the different methods as doing the same kind of thing, but at the end they also find that they just have different results when you try them. So yeah, I don't know.
Okay, or can you say again?
So okay, this is the thing here, like the part of this where I think a lot of the paper is trying to just like, because a lot of these methods already existed, like they invented steering or all of this stuff. They're just I feel like a bit of the intended contribution of the paper is doing like trying to frame all of those methods as this kind of with this math of like the behavior depending on different features that are independent and like have like you can save as a bunch of classifiers for each feature that
Yeah.
but I and they are trying to frame the interventions as in those terms basically.
I see.
I'm
Yeah.
not sure
Also,
that's how useful that
like-
is, but yeah.
Also in the tweet they said predict shapes. This isn't really predicting shapes. This is just assay features predicting assay.
Yeah,
So that's kind of I get baited. I was
Yeah.
expecting predicting manifolds.
they still yeah, I feel like they still they need to actually they have marketing for the manifold thing, but they haven't actually done the
There's no manifold in here.
unsupervised manifold
Yeah.
finding yet.
Let's see.
They keep baiting us
Manifolds.
with papers that look like they might be that, but not yet.
Manifold is mentioned once in the paper in the name of a reference. There is no manifold. No
Yeah.
shape. Okay, whatever. I think it's still a great paper though. It's a very interesting idea anyway. Okay, so let's say. Oh. You start by downloading a DPO dataset, which is just triplets that have like question, positive answer that you want, negative answer that you don't want.
Oh, it's always two answers basically.
Yeah, because you need to
Okay.
do the classification. So
Okay.
let's say you did supervised fine tuning on llama already using a different dataset.
So
Whatever. Now you do DPO.
So is the output like so do you like how do you get the reward? Like how do you actually train the model?
Yes, that's what I'm trying to figure out as well. Let's see. So let's say you want to do one epoch of DPO.
Yeah, or like one step of DPO.
Yeah. So you have the triple. How do you boil an egg? The question that the answer that is correct, the positive or y plus is like how do you boil an egg correctly with emotions, with emojis, and the negative one is also correctly how do you boil the egg but without emojis, I guess. Wait,
no, let's
what?
say the incorrect one is incorrectly how to boil an egg.
Yeah, it's actually incorrectly. It is not helpful because it just says you just boil water for a while the helpful one tells you for 8 minutes. So you want that one, but it also has emojis. Okay, sure. Yeah. Okay. Let's say you have 250,000 pairs like this, each label silently bundling every property that co-varies with chosen.
Yeah, for all that on the single step, what do you train?
Let's see. Let's go for step by step. So You want to
What
know
do
what
you
you're
need to
about
see
to
the
teach
model and
before
what
you
do you
teach it.
train it on?
So, okay, first you let's first do this. Like first you do the SAEs. So you train the SAEs on the model using yeah, whatever. It can be a general SAE with fine web, whatever. Sure. Features are very fine-grained, features are good. You have a lot of feature clusters, you're happy, great. Then you audit the data set, which means you run all the usable pairs through the model with the SAEs. So you take the whole DPO dataset of the reference pairs with the triplet. You run it through the model with the SAEs. And for each pair, you also get the different feature frequencies. So you get the chosen concepts, which is like the helpfulness, and the rejected, which is using emojis. Then okay. Okay. For each pair and each cluster, each cluster of SA features, compute the sign disparity per feature. So you get +1 if it fires on chosen only, and -1 if it's rejected, and 0 if both or neither. Okay. So if it's both emojis and helpfulness, then you get 0 in this computing the sign disparity. If it's only helpfulness, you get plus. If it's only emojis, you get 0 then, -1. Okay.
Okay, so I was looking at how I asked ChatGPT because I'm running out of cloud credits. If I understand correctly, the PO is just trying to train the model to assign more probability to like the correct response versus the incorrect one. So you just increase more on the correct one.
Yeah. That's the classification part.
So you just input
That's the
both.
correct tokens that you wanna reinforce, the correct ground truth. Ekper emoji cluster. See, that's why it's hard to call it reinforcement learning. Yeah. Ekper emoji clusters, emojis on chosen only. Well, that's not just that, whatever. Yeah. Emojis on chosen only. Never mind, they seem to be doing even more math there. That I didn't know about, okay. So helpfulness, completeness, chosen learning you keep. So as a result, you get a ranked list of their thing. So helpfulness, completeness, chosen leaning is keep in DPO. Emoji, enthusiasm, chosen leaning on causal prompts you explain away. Refusal,
Okay,
rejected,
apparently you have
leaning on harmful
the
prompts you explain away.
a reference model that you don't like
explain.
there's more there are more actually there are more steps in DPO apparently, like because you have a reference model and you take the difference in probabilities between the model without training with from the model after training.
Data essays, sure. Yeah, base model we have essays. For every triple, encode like efficiencies, cluster features. They are doing the clustering thing. I was completely missing the clustering thing as well. Okay, never mind. Pick the emoji feature. Max over response token, so that features activation projected from the G streams. Right, that's how you get the concept, sure. In DPO with the offset. You do log of the different policies. Policy plus x1, policy plus x1. Minus negative pairs. Logarithm.
About that. I know looking through the appendices in case there's something interesting. Yeah, there's probably a lot of things to read. I wanted to read the paper in more detail, but I don't know. Today I don't feel like doing that. Although someone wants me to look at some things, just tell me, but I don't know.
The reward is implicit in DPO.
Like at that point, it's
Literal
mostly
DPO paper is called your language model secretly a reward model. Secretly. Oh. Logarithm of the policy. Wait, that's logarithm of trained policy minus trained on the correct pairs given input minus logarithm of the frozen beginning policy.
Yeah, that's what I was getting.
On the
I got
correct
from
pairs divided.
ChatGPT earlier. That you are using the frozen original policy and taking the difference and not just trading on.
Yeah,
But
and that is equivalent to the reward implicitly.
okay, that makes sense.
Oh, wow, okay. That's actually very interesting. That makes
So is
sense,
it
yeah.
saying that classification is equivalent to reward to reinforcement learning?
I have a suspicion this other paper I sent, the reinforcement pre-training, is doing some similar move.
So is everything reinforcement learning?
I like and dislike it because at that point words lose meaning. I wish we could just communicate in math. That would be so much less vague.
I mean, I feel like at this point, like they are pointing to that if you communicate in math, then there is no way of distinguishing them in that they are only separated semantically, right?
Well, okay, let's communicate only in computable math. Each math. Okay, well, if you do not go right, there's too many isomorphisms, and you can abstract yourself to oblivion. But on the concrete level still, things are concrete. But there's still all these equivalences that just are mind-bending. Ah, Jesus. I think I would be satisfied if I would just read the DPO paper. Why
I
it
feel like,
works.
I don't know, at this point, unless more people have text, I feel like at this point is mostly, I mean, I could read more of the paper, but I feel it's mostly you trying to figure out the reinforming learning stuff, so we could just end the recording unless people have more text, and yeah, leave it this paper for today. I mean, you can keep going on trying to understand reinforming learning and the DPO and whatever, but you might as well just go read the DPO paper instead of looking at this one.
Maybe. But how do you do the reward shaping? Ah.
I mean, if
Oh,
okay, but
because you
if
have all the
if
different
I
policies.
understand it, sorry, what are you saying?
Go ahead.
So as I
Or you
understand
could
it,
say.
on the DPO works by you are trying to adjust some amount but not infinitely, like the probability that the model assigns to the correct response versus the incorrect response. So you are just changing the amount that you are increasing the probability of the correct response is if it has something that you don't want, like emojis. So, yeah, basically.
So how do you add the fact of removing the emoji concept in the DPO loss function or something
The
else?
DPO loss function is a difference of probabilities of the is this logistic function, so it's a number, so you can just decrease it.
So you have the log of the trained policy on the positive pair minus the frozen original policy on the positive pair, all of that minus on the negative pairs, the same formula.
Yes, so you just decrease it
And
by
how
the
do you-
activation of the... Decrease it by the logarithm of the activation of the sparse encoder, and that's it. So it's a
minus
on the
shape DPO.
it's like there was less difference in probability for the examples with emojis, for example. I think that seems simple and I still don't completely sure I completely understand all of the why this is ready for that, but I'm more confused at what you don't understand exactly, like what you're confused about.
How exactly do you encode the I don't want emojis part? I just wanna see a concrete equation.
You take the reward, you take the logarithm of the activation of the emoji feature on the sparse encoder, and you add
And you
it to the...
subtract it or
Yes,
add it to the
you subtract it
logarithm.
you subtract it from the reward, which is the logarithm of the difference of the true ones, of the difference in training of the true ones versus the preferred ones versus the dispreferred ones, or like correct versus incorrect ones.
I remember getting at a point where this was wrong. I think I was there already. What you're saying, I think, and I think I figured out
Maybe
was wrong.
you were correct and you went to become more confused, but I don't know.
Because I was still trying to put it into the reward, but there is no reward. There is only the
But there is
increasing the
this
probabilities
thing they
in
call
the supervised.
reward. Yeah, but there is still the thing with the call reward, which is a number, which is the logistic thing. That they are,
Yeah, the classification.
yeah, and they are backpropagating to with that as the as the thing to well, they are trying to minimize the loss. So I guess they probably add the reward.
Like, that would make sense to me, but I feel like I already debunked this model. Okay.
I mean, if you don't remember how you debunk, maybe you're just wrong and you wrongly debunk it. So
Maybe. I just wanna see the code and the math more directly.
I think if they probably they didn't release it the code, right? I mean, they probably
Yeah,
want to
probably.
sell their pipeline or whatever for to companies,
Yeah.
so makes sense.
Okay, let's see if this math makes sense. So vanilla DPO loss is just minus logarithm.
By the way, here also, when the reward itself, here they are talking about reward in general, but here they say, when the reward itself introduced by a language model, as in TPO-like protocols, where likelihood rate ratios serve as rewards. This
By a language
correction,
model.
okay, go back to reward shaping and actually read it.
When the reward is itself induced by a language model, as in DPO-like protocols, where likelihood ratios serve as rewards. This correction can be applied directly to the reward model logit or likelihood ratio term.
Oh yeah, it's basically just that. Like on DPO, you have a likelihood ratio between the correct and the incorrect one, and you decrease it or increase it or whatever. Decrease it in this case.
Yeah, that makes sense.
And if you are
Like-
doing PPO and have a reward model, you just decrease the reward of the reward model.
Yeah. That makes sense.
Okay, anything else, or do we just end the end the recording?
I will check it in more math.
Okay, yeah, but I still think end the recording unless other people have more take,
Sure.
because I feel like we're kind of not talking that much now about the actual paper. Oh, people are pinging me on Discord. Anyway, I'm going to remove. Yeah, I'm going to stop the recording.